Your safety and the safety of the general public are of the utmost importance when carrying out your job. National Grid's line of sight objective has the aim of driving improvements in our safety as well as customer and operational performance. It is supported by National Grid's Golden Rule initiative, which places emphasis on the correct use of safety protection systems and devices. This program covers electrical safety when undertaking meter, mains and service work as required by our policies and procedures. We have had some serious incidents involving electricity when going about our work, and it's important to keep safe. A risk assessment must be carried out prior to undertaking work. We'll be looking at using the volt stick, temporary continuity bonds, locating hidden pipes and cables, electrical insulation joints, and protective bonding. The National Grid approved volt stick is used for detecting the presence of AC voltages above 50 volts on exposed metalwork. It's been specially designed for National Grid and can be used in gaseous atmospheres. It's weatherproof but not waterproof and is powered by 2 AAA batteries. The volt stick must always be used before touching any metalwork in the work area, for example when working on a meter, or carrying out any metallic mains and service or internal installation pipework. Before beginning work, it's important to test the volt stick. This must be done every workday against a known 230 volts electrical supply. Hold the blue body, not the white tip. It should be held close to a main supply and the tip should illuminate to show that it's working correctly. Each time before it's used, it should be rechecked in the way we've already seen or by rubbing the tip on clothing to create a static charge. If it doesn't illuminate, check the batteries. Faulty or damaged volt sticks must not be used and must be replaced without delay. All bare metal gas pipes and fittings within the working area must be tested before they're touched. The only contact with the metalwork must be through the tip. Do not touch any other metalwork with any part of your body when making these checks. Other metalwork that is in close contact with electrical cables, including metalwork connected by earth bonding cables, should also be tested before it's touched. This includes metal pipes, services and conductive parts such as metal sinks and cookers. The volt stick will illuminate through the insulation of most domestic electrical live cables. It will also glow when it's close to cooker and boiler mains control panel cables, but this does not necessarily indicate an unsafe situation. In this case, the body of the appliance has indicated an unsafe condition, so the next step is to check further away from the mains cabling. When checking the metallic gas pipework, if the volt stick does illuminate, then follow the procedure in the appropriate flowchart. The volt stick detects AC voltage and will not detect electrical current. It should not be used as a detector of live power cables. There may also be situations where pipework could be at a low voltage that is undetected by the volt stick. Remember that a very small voltage, while not being capable of electric shock, can have enough energy to ignite a gaseous atmosphere. This is one reason for the use of temporary continuity bonds. Temporary continuity bonds prevent sparking and protect against electric shock by keeping two adjacent sections of pipe at the same electrical potential. A temporary continuity bond must be fitted before disconnecting any part of service pipework, a meter installation, or other metallic pipework, including metallic mains. And it must be fitted in a position so that it remains connected until the work is completed. Where an insulation joint is fitted, the temporary continuity bond must not bridge across the joint, except where the joint is incorrectly fitted above the emergency control valve. This ensures that safety is maintained in the unlikely event of a high current being carried by the continuity bond under electrical supply fault conditions. Depending on the work being done, a handheld cable detector should be used to detect any hidden pipes and cables, for example, before drilling and fixing when moving the meter bracket. Cables and pipes may be concealed behind false panels, plasterboard walls, or buried in concrete or plaster. Although the probable route of cables may be apparent from the position of switches, junction boxes and other electrical equipment, it should not be assumed that all the cables run horizontally or vertically. Where the handheld detector gives a positive reading, then you must not drill within that swept area. Handheld detectors are not suitable for use in gaseous atmospheres. You should also be aware that handheld detectors have a number of limitations. These include depth of detection, indications caused by damp surfaces or static charges, resolution such that nails and screws are detected instead of hidden pipes and cables. Before using a handheld detector, the manufacturer's operating instructions must always be read and followed in full. Direct current leaking to earth from an electrical appliance through this pipework resulted in significant localized corrosion where the pipe wrapping was damaged. This property was severely damaged in an explosion which followed the gas leak. An insulation joint would have prevented this by stopping the flow of electrical current through the metallic gas pipework. The joint consists of two metallic halves separated by a ring of non-electrically conducting material. The insulation joint should be fitted directly below the emergency control valve. It's necessary to insulate any exposed, bare metallic pipework upstream of the joint. This can be done by wrapping the pipe in a suitable insulation material. Insulation joints are required on inserted steel services, where the termination is inside the premises, and on new steel services, for example, buried steel entering industrial and commercial premises. Insulation joints are not required where a PE service continues above ground. Protective bonding is the term used for cables connected between adjacent pipework and metalwork. This ensures the installation remains at the same electrical potential. There are two types found in properties. Supplementary bonding conductors are usually found in bathrooms and kitchens. These should not normally concern us. The green and yellow bonding cable found on the gas supply pipework close to the meter is known as the main protective bonding conductor. It's connected to the main earthing terminal on the consumer's electrical supply. The correct position for the connection to the gas installation is on the meter outlet pipework within 600 mm of the meter outlet union. It should be visible and fitted before any T-joints. Where meter boxes are used, the distance is measured from where the pipe enters the property. It may be fitted on pipework inside the box or on the external installation adjacent to the box. Where the bonding is attached to the pipework, a safety warning label must be permanently fixed stating, "Safety electrical connection, do not remove." Different cabling configurations are used by the electricity distribution company to bring the mains power into a property, commonly in one of three ways. In the three-cable system, the three conductors, live, neutral and earth, are continuous from the property through the electrical distribution system and back to the electricity company supply transformer. More recently, protective multiple earth or PME systems have been used, where the neutral and earth conductors are combined. In some cases, a PME system may be identified by a label at the supply cutout or meter location. Only two conductors are run back to the supply transformer, the live and the combined neutral and earth. This combined conductor is earthed regularly to limit its maximum voltage to around 14 volts. You should be aware that under electrical fault conditions, it's possible for the gas pipework to be carrying a significant electrical current and a voltage greater than 14 volts. For example, if a break occurs in the neutral conductor outside a property, current can pass along the path indicated using the protective bond and gas or water pipework to bypass the break. In this situation, harmful voltages could exist across pipework when cut, split or otherwise broken apart. There have been isolated instances where this type of fault has occurred and resulted in the gas pipework acting as a neutral conductor for the electrical supply. The two-conductor TT system is often found in rural areas where there are overhead supplies. Live and neutral conductors are connected to the supply transformer and the property has an independent earth through an earth rod. Service pipework must not be used in place of the earth electrode. However, there have been instances where this has been done, and the installation pipework became live when an electrical fault occurred inside the premises. When carrying out service relays, you may find the protective bond is fitted correctly, fitted in the wrong location, or not fitted at all. The fitting of the main protective bond is a requirement of the British Standard 7671 and a legal requirement for PME supplies. The Gas Safety Installation and Use Regulations require that National Grid notify the property holder where it's recognised that a protective bond should be fitted but is not, or where the protective bond is incorrectly installed. This requirement to inform the property holder is regardless of the electrical supply earth configuration encountered. If the bond is fitted correctly, then continue with the work. If the bond is in the wrong position but the work is not affected by it, then continue and leave the standard safety notice to inform the property holder of the situation. If the position of the bond is such that you cannot proceed with the work unless it's disconnected, then the bond will need to be relocated. This must be done by either a qualified electrician or a person who has successfully completed the company's training course MEB1. If the bond is not fitted at all, then the work may continue, but again the customer must be advised using the standard safety notice. To sum up, you should use the volt stick before touching any exposed metalwork. Install temporary continuity bonds before disassembling any pipework. When necessary, locate all pipes or cables within the work area. Fit insulation joints if required. Identify the type of electrical installation system. And follow the guidance for protective bonding. If you follow these simple guidelines, your safety and that of the public will not be at risk.